Imagine a cosmic nursery, billions of light years away, where a newborn star is taking its first breath. This celestial infant comes to life in the heart of a nebula, a vast cloud of gas and dust. Here, the elements of life, primarily hydrogen and helium, are in an eternal dance, swirling and mixing under the influence of gravity. As these elements come together, they form a protostar, the infant stage of a star's life. The gravitational pull at the core of the protostar becomes so intense that it triggers an extraordinary event, nuclear fusion. In this process, hydrogen atoms combine to form helium, releasing an immense amount of energy that lights up the star and sets it aglow in the vast cosmic darkness. However, for some stars, this is just the beginning of an even more fascinating journey. As the star exhausts its nuclear fuel, a dramatic change begins. What was once a shining beacon in the cosmos now stands at the precipice of a spectacular transformation. This is no simple metamorphosis, but a cosmic event of epic proportions. The star, in its twilight, runs out of nuclear fuel. The nuclear fusion, which was the lifeblood of the star, grinding to a halt. This fusion was responsible for creating an outward pressure that balanced the immense gravitational pull from the star's own mass. With the cessation of fusion, this delicate balance is disrupted. The star's core, now unopposed by the force of nuclear fusion, succumbs to its own gravity. This results in a gravitational collapse where the core implodes, compacting to an unprecedented density. Imagine the mass of our sun, over 1 million times the size of Earth, collapsing into a sphere with a diameter of just 20 kilometers. That's a density so extreme that a mere teaspoon of this material would weigh about as much as a mountain. Meanwhile, the outer layers of the star are not idle. As the core collapses, it sends a shock wave that ripples through these outer layers, causing them to explode outwards in a brilliant supernova. This is not the gentle glow of a star, but a violent explosion. One of the most energetic events in the universe. For a few weeks, this single star outshines an entire galaxy, a fleeting testament to its former glory. The aftermath of this cosmic spectacle is what we call a neutron star. These are the remnants of the collapsed core, composed almost entirely of neutrons. They are the densest and smallest stars known to exist in the universe. But not all neutron stars are the same. Some of them, following their dramatic birth, hold an even more fascinating secret. This secret is what sets them apart, what makes them not just neutron stars but pulsars. But that, dear listener, is a tale for another scene. In the heart of the neutron star, the core's collapse sends the star's rotation into overdrive. Picture this. The star, once a calm, luminous ball of heat and light, now transformed into a rapidly spinning top, its core compressed into a dense neutron soup. It's a cosmic ballet, choreographed by the laws of physics, and it's about to get even more interesting. As the neutron star spins, it creates an intense magnetic field, 1 million times stronger than the strongest magnet on Earth. Charged particles trapped within this magnetic field are whipped around at nearly the speed of light. The energy generated is so massive that it can't be contained, and it bursts forth from the star's magnetic poles in the form of beams of electromagnetic radiation. Just imagine it, beams of energy, each one more powerful than 1 billion suns shooting out into the cosmos. It's a spectacle of cosmic proportions, a celestial light show that dwarfs anything we could ever dream of on Earth. But from our vantage point here on Earth, we can't see these beams directly. Instead, we witness this cosmic spectacle as a pulsar. As the neutron star spins, its beams of radiation sweep across the cosmos like the beam of a lighthouse, creating a pulse of light and radio waves each time they pass our line of sight. It's this rhythmic pulsing that gives the pulsar its name. Each pulsar is unique, its pulse rate determined by the speed of its rotation and the strength of its magnetic field. Some pulsars pulse once every few seconds, while others pulse hundreds of times per second. It's like a cosmic heartbeat, each beat a testament to the incredible forces at play within the star's core. So there you have it. The birth of a pulsar, a celestial object of immense power and beauty, born from the death throes of a star. It's a process that takes millions of years and involves forces so great that they're almost beyond our comprehension. But what does this mean for the universe around it? That's a question for another scene. Pulsars, with their intense magnetic fields and rapid rotation, are some of the most extreme objects in the universe. These celestial powerhouses are not just fascinating to observe, they're also integral to some of the most cutting-edge discoveries in astrophysics. One of the remarkable effects of pulsars is their role in generating gravitational waves. These are ripples in the fabric of space-time itself, caused by the acceleration of massive objects. Think of it like tossing a pebble into a pond. The pebble is the pulsar, and the ripples are the gravitational waves. These waves carry information about their cataclysmic origins and about the nature of gravity that cannot otherwise be obtained. They are a key area of study for physicists trying to understand the fundamental workings of the universe. But pulsars aren't just cosmic laboratories, they also have the potential to host planets. Which brings us to another astonishing discovery. The first planets outside our solar system, or exoplanets, were not found orbiting a star like our Sun, but a pulsar. In 1992, astronomers discovered a system of exoplanets around the pulsar PSRB 1257+12. This was a surprise, as pulsars are the remnants of supernova explosions which are typically destructive to any nearby planets. Yet somehow, these pulsar planets survived, or perhaps formed from the debris left over after the supernova. It's a tantalizing mystery about the resilience and adaptability of celestial bodies. It also shows the potential for diversity in the universe, where even the harsh environment of a pulsar can give rise to a planetary system. So the transformation of a star into a pulsar isn't just a cosmic spectacle, it's a testament to the incredible dynamics of our universe. From the generation of gravitational waves to the potential for hosting planets, pulsars are helping us uncover new and surprising truths about the cosmos we inhabit. Our understanding of the universe is being shaped, stretched, and deepened by these extreme objects every time they pulse.